So suppose that we wanted to find the average length of all of the fish in Lake Louisville at this moment in time. Is that a value that is known? No. How come?
There's nobody to calculate.
Everything is changing. There's constantly fish dying and being born. Just kind of sad, but things are changing all the time. Could we go figure that out right now?
No.
We can't. We can't.
You would kill all the fish trying.
So if we did know that value, we would call that a parameter. So what I want you to do on the left side of this paper that is completely blank, I want you to make a T-chart, and you're going to label it. So I'm just going to start with one. On the left side, you will say parameter. And then underneath, in parentheses, you will put population. A T. Have y'all been in elementary school before?
Not really. It's been a while.
We went to a straight.
So parameter underneath, I want you to put population, and then on the right side of the T-chart, I want you to put statistic, and then in parentheses, sample. And I'm going to explain what all of that is in a second. So a parameter is a fixed value about the population, and like we've discovered, it's typically unknown. You would have to actually have a census to gather all of the data for everything. So parameters in this school that are known are like how many students we have at this school. We have a physical count. We have the average GPA, and I know it's like always changing every day at this school, but at the end of the school year, last year, they did an average for every student across PCA. So that would be a parameter. I have no idea. That would be a parameter, meaning it is known, and we could go to the counseling office right now and ask Dr. Moss, and he would give us the actual number. So that is something that is known, and it is fixed, and it's not changing until next year when we get another count of everyone. So this one could be known, but it's typically unknown, especially for large populations. So if we don't know, for instance, we don't know what the average length of fish is in Lake Louisville, we can try to estimate this unknown parameter. So that would be called a statistic, which is the value that's calculated from the sample. So whenever we did the goldfish thing, I was withholding information from you, and I said that there is a certain percentage of fish that don't smile and fish that do smile. And I wanted you to try and figure that out. So what did you guys do? You took samples and you tried to guess, and we got pretty close when we did our dot plot because all of us took 10 samples of 5 fish. So everybody in here had 50 fish, and we combine all of that. That was almost 300 fish. I know there's millions of goldfish in the world. We had 300 of those, and we tried to guess. And so that would be a statistic. Whatever value we got when we did that, that was a statistic, but the 0.42 was the parameter. That was the actual proportion of fish that smile in goldfish. Do you have a question, Avery?
Kind of, but I'll ask you later because I can't figure out that.
Okay. So the measures of central tendency. So like the C part of CUS, there's mode, which we don't use because it doesn't really give us information. But if I did ask you what's the mode of something, it's what occurs the most often. But at the bottom it says not used as often as mean and median. So we don't use mode in our cussing. We just use mean and median. But mode does fall under a measure of central tendency. The next one is median. It's the middle half to find. If you have an odd set of values, it's the middle number. If you have an even set of values, it's between the two middle numbers, and you take the average of those. So if I had 21 data points, which data point would be my median?
11.
The 11. Good. If I had 20 data points, what 2 would be the middle? the 10th and the 11th, and so I would average those two. And that obviously only works if you've ordered them from least to greatest. But the really nice thing is we never, ever, ever have to do that by hand. So our calculator will do it for us. When we see the letter N, that's usually, it's always considered our sample size. So if I said N equals 20, that would mean our sample size is 20. And so just looking at this, our median would be what? 5. So smart. Looking at this one, the median would be 5.5. Good. The last measure of central tendency is called the mean. There's two symbols for mean, whether I'm talking about population or sample. So what I want you to do is go back to your little T-chart. So scroll one page back. We're going to add to it. So we had population and sample. The first thing we're going to write in is our symbols for mean. For population mean, we represent that as the Greek letter N, which we say mu. Mu. And for sample, we say X bar. X bar mu. A good rule of thumb is anytime you see a Greek symbol, it's talking about the population. And anytime you see the English alphabet, it is talking about sample. So if out to the side, if you want to put Greek and English alphabet, that's a good way to differentiate when you see the two. Because notation in this class is huge. If you put mu equals and you should have put X bar, going to count it wrong. And once again, mu is considered a parameter. It is something that is known. And X bar is considered a statistic. It's something that we calculated that we're guessing is trying to obtain the parameter. Here's the formula. You don't need it. You can cross it out. We're never going to have to do this on our own by hand. Sometimes statistics teachers are mean and they make everybody do this class without a calculator. I don't know why anyone would do that, but they provide the formulas for you in case you forget how to use the calculator on the test. And I don't think that'll happen to you, but it could. Yes?
So we use the M and not that little sign to represent the population. Right?
The population, that's a mu.
That is a mu?
Yeah.
It just looks different.
Just kind of looks like a little curly U, but it's an M.
Okay.
Yeah.
So
Just the way that you,
yeah. Obvious that it's not
Yeah.
X bar.
Okay, so if I wanted to find the average of these, I would add them all together, and I would divide by however many we have. So there's 6 of them, divide by 6. Like I said, I'm not going to make you do that by hand. But our sample mean would be 6. The next part is we're going to gear towards finding measures of variation. So those were all central tendency, center. And actually what I want to have us do is make another chart below our T-chart. And I want you to put central, well, I don't know why I'm writing it down there. Yeah, underneath at the bottom of the page, central tendency or center, and then variability, which is just our spread. Because oftentimes the AP test will say, what's the best measure of center measure of central tendency to use in this type of equation or this distribution? And they'll give you every single option for center and spread, and it's sometimes hard to differentiate. So if I'm talking about the center, I'm just saying mean or median. And I would want to use the median when my data is skewed, which we're going to get to in a minute. But maybe out to the side, you might want to put the word resistant And we'll get to that in a second. Resistant. Then we're going to get to variability in a second. So those are the two for center that we can use. So when I'm talking about spread or how much the distribution is spread out, we've already talked about using range. This is going to lead us into what standard deviation is. So imagine I took all of my data points and I counted how far away they were from the mean. And I want you to just look at the chart right now, and I'm not going to make you ever calculate this by hand. So this is why I just kind of talk through it so you can understand what standard deviation is. Because you probably heard the word and you might have even seen it on an SAT and just never realized what it is. So if I've got my distribution and my mean is 6. So here's my chart. 6 is in the middle. And then I've got 3, 4, 5, 8, and 10. And I am taking all of those data points and subtracting the mean. So some of them are negative because they're below the mean. Some of them are positive because they're above the mean. And 6 would be 0 because it is the mean. And if I added those up, they would all add to 0. And that's going to happen every single time. Because if you calculated the average correctly, then all of those sums would add to 0. So I want you to write deviations always add to 0. If I'm simply taking each value and subtracting the mean. They're always going to add to 0 no matter what. It's kind of like you're balancing, and the mean is considered your balance point. I think so. We have a set of data, and we are going to hit the stat button and then edit. So stat, edit. And I've got stuff in there. If anybody has stuff in there, you're going to, no, don't hit clear yet.
It's under the delete button.
Go up to the top where, see my list 2 is highlighted, or my list 1 is highlighted. Then hit clear and then down. Stat edit. Stat edit. So if you have stuff in there, I'm going to highlight my list at the top, hit clear, and then scroll down.
Wait.
You want it clear.
Don't ever delete a list. Listen to me. Do not ever delete a list. Your calculator will blow up right in front of you. It'll just implode. So don't do it.
Wait,
Don't delete a list.
that's clear. What do you mean?
Just clear.
Yeah, just clear. Don't delete.
Oh, like delete every single one of them.
What? You have to highlight list 1, so click the up button,
If you press the delete button,
clear, and then down.
Like in the process.
So you're going to go to stat. Then you're going to scroll to the right to where you see calc and 1 bar stat. So just hit enter. You're going to leave list 1 like it is, because that's what we're keeping it in, is list 1. Our frequency list, we leave blank. You should have nothing in there. We don't know what that is yet. And then we're going to hit calculate.
Just take that.
It says
Uh-huh.
error.
Oh, that's
so convenient. Well,
If you, the first thing that they give you is your mean. Now you have to decipher if it's the mean of the sample or the population. It's always going to give you this symbol no matter what, because your calculator doesn't know if you're doing sample or population. But it's the same rule for both of them. So let's say that the population of the lake was only 20 fish, and I had all of that data. Then on my answer here on my worksheet, I would need to say mu equals 6.5. So it'll tell you in the problem whether it is mean or population. You have to use your brain to decide what symbol to use, because the calculator is always going to say this. It's not smart enough to read the problem and change the notation for you. I would say 9 times out of 10, we are always going to be doing sample. Like at least 90% of the time we'll be doing sample. The next thing that it gives you, we do not need. It's like if I took all of my data points and added them together, we don't ever need to use that. And the second thing would be if I took all of my data points, added them, squared them, and then added them together. So we don't need that.
What would that be useful for?
If you're calculating standard deviation by hand. But you're not really calculating it by hand because you're using the calculator. So those are the steps of the process to plug them into the formula. The next two we're going to learn about, but I'm just going to go ahead and tell you what they mean so that we don't have to go back and do this, are the 2 standard deviations. The first one is called our sample standard deviation. And how would we know it's sample versus the one below it? Yeah, because it's an S. And then this symbol is called a sigma, which is like a lowercase s in Greek. And that would be my population standard deviation. Now those numbers are different, and I will tell you why in a second. The next thing that it gives you is your sample size, and I don't know if you'll really ever need this, but just a good reference to have. We have 20 data points.
Is that what the N is?
N is sample size. If I scroll down, so hit the down button, the last part of information that it gives you is what we call a 5-number summary, and which is the minimum, Q1, median, Q3, and max. And what all that we need right now is just the median. But once we start drawing box plots, you will need all 5 of those pieces of information. Really all we need right now is just the median.
Is Q1 and Q3 like 4 times?
Uh-huh.
Oh.
Yep. So now that we've done this information, I want you to fill in the page. So it's asking you for the mean and the median. They're both 6.5. And I want you to graph those data points onto the dot plot that you see at the top right. So graph those onto a dot plot.
The like 35.
Uh-huh. So I'm going to make myself a note that when a distribution is symmetrical, the mean equals the median. They are the same. When something is symmetrical. So the next piece of information, or I guess the next thing that it wants me to do, is it wants to change my 10 inches to 15. So I'm going to go back into my calculator and so stat, edit, and is this the only 10 I have? Right?
Yeah.
Okay, so what I'm going to do from there is this is the only time I'm going to let you hit delete, but I'm going to hit delete.
You can
Or you
just
just
type
type
over
on
it.
top of it.
Oh yeah, you can just type over it. They're so smart.
Yeah, how do I get out of this?
So I'm going to delete it and then go to the bottom and type 15, but you can just type over it. Then I want to calculate a new mean and median. So stat, calc, enter, calculate. So my new mean is 6.75, but my median is still 6.5.
Is there a symbol we need to put for median?
No, just median
And do we put like it equals or just like put it in front of it?
equals. And so what do you notice happened? What changed and what didn't?
Mean went down.
The mean went up
Median stayed.
and the median stayed the same. And if I were to represent that on my graph, so this is a histogram, but for you guys, what I did is basically I took this data point and it went away, and now I put it over here. And that actually caused my mean to be 6.75. So that drug my mean up a little bit. So
Is 15 an outlier?
15, yeah, it could be an outlier. So that made my mean increase because I took one data point and I shifted it up. And so what that is saying is that the mean is not resistant to outliers. So let me, I think it's back here on this slide right here. There we go. Here. So statistics that are not affected by extreme values are said to be resistant. So extreme value meaning that 15. I consider that an extreme value because it was way out in the middle of nowhere. Something that did not get affected was the median. So I would say the median is resistant, but the mean is not. And why did the median not change? I didn't add more data points. I just changed a very extreme one. But the median still stays in the middle, very comfortable in between two sets of data. Yes?
So if you had changed a point that wasn't 10, like say you changed like 7 to become something higher, would
The only way it would change is if you changed the middle point. But if you're changing the outside points, it's never going to change. And that's what being resistant is it's affected by extreme values, meaning the outer values.
Okay, so like if I had like a 5 and I made it like an 8, so there's one more on the other side of the mean, then it would change.
Right. But being resistant means it's affected by extreme values, which means the outer ones. So the mean is not because it actually increased it. So I like to think about if we have a test grade and so everybody did really, really poorly on it, but one person got a 100, then that's going to pull the mean a little bit higher than it actually should be because everybody scored really low, but one person made 100, and that actually pulls the mean towards 100 or a little bit higher. Okay, go back to your fish length page, and I want you to put in set number 2. I want you to try putting in set number 2.
Don't do this.
So you can either clear your list 1. To do that, you want to highlight list 1, so go to the very, very, very top, keep hitting up until you can't hit up anymore. Hit clear, and then the down button, and that's going to clear your whole list. So we got 6.8, and the median is 5.5. So what do you notice about the relationship between mean and median and the shape?
Mean is bigger than the median.
Mean is pulled in the direction of the skew, so the mean is greater than the median in a right skew. Mean is greater than the median in a right skew. And then let's get practice one more time. Clear that list and try try a third time that you can guess what shape that one will be. What is the mean?
7.75.
And the median is?
5.
So what do we notice about the shape of this?
It's a left skew.
Left skew?
Bigger.
Mean is less than median in a left skew. So, summary is if the mean always pulls towards the skew, no matter what. Just a recap. In a symmetrical, they're equal. Skewed, they go in the direction of the skewness. In a symmetrical distribution, you should cuss using the mean. In a skewed, you should cuss using the median. But like I said, if you always use median, there's nothing wrong with that. You will always get full credit for always using the median. When you're answering like multiple choice questions, a lot of times they'll ask you like what's the best one to use. And typically they give you a skewed distribution and they'll test you on whether you know to use median for skewed. Yes?
Could you not use the mode if it was like a symmetrical with the really tall point?
You could, but we just don't really ever talk about using the mode in cussing, just because they don't do it. So we just have to know what that is. But the last thing to talk about today is a trimmed mean. So go ahead and go back to the PowerPoint. The purpose of a trimmed mean is to get rid of the outliers. The only caveat to that, and because sometimes when we're calculating our averages for tests and things, we want to use a trimmed mean to get rid of the lowest one. But when you do that, you also have to get rid of the highest one too. So it's only accurate if you're cutting off one from the bottom and one from the top. Okay? So to calculate a trimmed mean, you have to multiply the percent to trim by your sample size and then truncate that from both ends. So what I mean by that is here's a set of data. Here's the mean right now as it is a 23.8. There are 10 data points here. And if I said find a 10% trimmed mean, how many of those, oh, is that the bell for us? Oh, one data point from both ends.
So why would that not be?
So you're actually cutting off 20%.
Yeah, 20, yeah.
Yes. So a 10% trim mean is like cutting off 20%.
So if it was 20, it would be 40.
Yes.
Yeah.
Okay, and we'll talk about that a little bit more next class.
What is the